How you doing? Doing all right.
Yeah.
Yes. Do you want to go first, or do you want to go?
I have no preference.
Why don't I do the geometry part? That will definitely be done by 11, and then that'll be okay.
Sure.
Okay. Let's see. Okay, I'm trying something a little different in my setup, so I'm gonna use my screen here. What you're looking at is actually the live stream software. So this is actually the recording, so that if the recording starts to mess up, you guys will see. Because there's been some times where you guys saw it just fine, but my recording software was kind of whacked. So hopefully this will do two purposes, and then because I'm behind a monitor, if you need to see my face, like I said, I'm still lower. I'll put a little webcam here. And it'll kind of, while I'm looking here, working on it, it might be easier. We'll just see. It's I tried it last night and it seemed to work pretty good. Let's do this. So this is the first chapter for most classes. It's the last chapter for us. So today's the last day of new instruction. Next Friday I will be out presenting at a conference, but what I'll have for you, I forgot to get them now, but I forgot to get the print out the final exam. So if you want to wait after Macaulay, right? McKaylee. That's why the other girl that went out was Macaulay, so I was, yeah, McKaylee. After McKaylee's presentation, I'll make copies of the practice final exam if you want to take those with you. It is in Canvas, so if you want to just print it out on your own, that's fine. But if you want hard copies, I'll get those at the end of class. Okay. Any questions? Okay. So I did make an extension on the 200-point extra credit. So there's 40 points of extra credit as long as you have 200 points by the end of this weekend. I think most of you here probably are fine. You probably already got it. Again, if you have the 200, I've already put those in. But I will be updating grades again this weekend, and anyone who can get to that 200 level mark, you'll get the 40 points of extra credit. And that will make it more doable for some of those who are under 100 or something. You know, get to at least 200. Let's see. After today, this will be 12, so 11. You should be at least 440 actually if you've done all the homeworks. And again, with extra credit, it's possible. There's a couple people in class who've presented already, and I throw those in, and they're already at a low B without even taking the final. That's a good place to be, because the final's worth 250 points, and if you're at a B already, you'll only need probably less than 100 to get an A. So that's a good way to be. So those are the options. It's if you do everything, do all the extra credit, you'll be in good place. Also, maybe I should pull that up here. I added in the extra credit for, let's see, in Canvas. Let me just do a quick introduction to where that is. It's videos on Mayan math, and all you need to do, come into the course. Let's see. Do this. Let's go to modules. You go in through the assignments, and you'll see it's right here, Mayan Videos Extra Credit. Click on that. The assignment actually comes up, and it says you'll get 40 points, which is a whole chapter in itself, by watching the videos at these links. I'll go there next. And then what you need to do is you need a, what do we need to do? Write a brief reflection of at least 1.5 pages, double space, so that's like only 3/4 of a page, a full, where you discuss the mathematical discoveries involving language arts, codes, and stuff that you found interesting. So it's not, you can't miss anything. It's what was interesting to you. And when you click on the historical math video lessons, these are they're all in YouTube. Someone posted these. They're in, like this first one's only 3 minutes, 2 minutes, 4 minutes, 3 minutes here. So they're broken into pieces. Or you could watch the whole show, which is Cracking the Mayan Code. It's 1 hour and 20 minutes. And what I did is I started watching a little bit. I found these little ones, and I said, oh, here's the whole show. And I watched the whole thing. I've watched it 2 or 3 times. It's kind of interesting. I find it interesting. Not everyone will, but if you're into like the math of archaeology, this is a great sort of stuff. This was one of my favorites, though. This little kid, he's a 10-year-old kid, is working where his dad's the professor down there working, and he's the one that's sitting figuring out a lot of this stuff because he's doing the drawings and stuff. So that was kind of cool. Anyway, they're there. Watch a few of the videos, enough to write up 1.5 pages, double space, on what you found interesting. Okay. There's a place right there in the assignments. So we go back. You actually, there's a little button up here that says submit. You click on that, upload your paper. It's right in the grade book, and I'll take a quick read of it, and you got another 40 points of extra credit. But it's also, it's a good unit in itself. Okay? So, we're going to talk about geometry. And basically we'll teach this through looking at several different problems, sort of doing a problem approach to finding it. But there's really sort of 3 main concepts. So we're going to talk about perimeter. Which is if we have a building, I've got a few videos on this, you'll see these. It's the how long around the building is it, right? You go take a walk. So that's perimeter. Second thing we're going to be talking about, area. So the area is taking that same building or whatever and finding out how much space is on the floor space. Okay? And then the third thing we're going to talk about is volume. So that's 3-dimensional space, so it might be like space inside of a building or something where you have, this is my terrible 3-dimensional building. Sort of, so it's how much airspace, for storage and stuff. That's volume. So we're going to look at the 3 different things. We're going to look at ones that are rectangular, squares, triangles, and then we're going to look at circles as well. Okay. But if you've had if you've had a geometry course, say like in MAT141 a while back, This is a little bit more of applied geometry. So we're going to learn how to take them, but then we're going to use the geometry to sort of solve some problems as well. Okay. So let's first take a look at these videos. Hopefully it still works. We'll haven't looked in a while. It goes into YouTube or some formula. So area of a rectangle. How do we find the area of a rectangle? Let's watch this little length times width, divided up into a bunch of little squares, and there's your square units, and you just count them basically. But we're going to see you can also take length times width. So these are little animations. You can kind of come back and you'll see it's L times W. That's how much the area is. Okay, and this is in this PowerPoint is in MAT141, so you're welcome to pull it up. And unfortunately, the link's at the end. I just changed it to make it closer here. But so that's a rectangle. They do one with a parallelogram, and there's basically, if you cut off the triangular part, move it over, what do we have? We've got a rectangle. So what we see is it's base times, but it's the height of the rectangle, not the slanted height. Okay, so not the slanted height, but the height itself, the vertical height. So that's a parallelogram. They have two ways of doing a triangle. So one way of doing the triangle is we could draw it this way. Here's its height. We cut each of these in half and make another cut. This is kind of the complicated way to do it. I don't think I could draw that, so that's why I show you this. But we get a rectangle that way. Okay, and it's half of the base times the height, because the base gets cut in half. Okay, that's a little bit abstract. What I like is the, let's see. If we go to triangle 2 is the way I would have drawn it. You take a triangle and then you basically duplicate it, make a copy of it, and then move it around, slide it up, and you've got a parallelogram, but you've got twice as much area now as what you started with. So you take the area of a parallelogram, which is base times height, but since we only have one triangle really, we made the second one, it's half of it. Okay, so we'll apply some of these, but there's a little picture on doing it. Trapezoid's kind of the same thing. We'll get to the, I think it's the second one, so I'll let you take a look at the first one if you like. But there's a formula also for the trapezoid, and it kind of follows this one. You make a copy of it, slide it up, and now what you have is you have the base from the top and the bottom. So your bottom base is base 1 plus base 2, multiplied by the height. And again, since we made a copy, the area is actually only half of it. Now you don't have to memorize these formulas. These will be provided for you. There's a formula sheet. Like I would ever really remember it. But these animations help you see kind of where those things come from. The circle, there's two of them, and in this one I think I would go with the first one. I believe is the better one. The second one's a little abstract, but this is how I would do it. They do a better job. Cut it into like a pizza, put them aside, put them together. You kind of got something that looks like a parallelogram with half of the circumference on top. And the height is the radius, so base times height is pi times r squared. Okay, so it's basically, you know, that's how we're going to look at circles as well. But again, we'll use the formula, we'll apply it on several different things and using them, and you should be just fine. But if you'd like to review back, there's these animations, and I think they're helpful. They've got so the links in the PowerPoint. Okay, those go. So that's that. So again, we talked about, oops, come back. When we're getting perimeter, it's going to be linear units, length in inches, feet, miles, centimeters. Then when we measure area, say for carpeting, it's going to be in square units. Literally, little squares is what we're measuring with. And then when we get to three-dimensional, we're going to have little cubes of how many cubes fit into a room. So perimeter. And again, you might watch some of the videos that I have. They'll kind of do it. So how do we get the perimeter? Oops, I'm in the wrong place. I'm so used to looking over there. What's that? That's for area. So perimeter, what you want to think about is the little guy is going to walk around the building. So we're just going to add all the sides together. So we're going to, for this one, we would take 11 and keep walking. We'll walk this way, so we're going to add on 4 centimeters. And the question is, when we get along the top, they don't have anything here, but how far is that? It's 11, because we just, yeah, so on these, we can add that together. So we'll add another 11, and then on the back side again, even though it doesn't say anything, it's got to match this side, so another 4. What's that? You can, yeah, there's a perimeter formula, which is 2 times the length plus 2 times the width. That'll be on the formula sheet. But I encourage you with perimeter not to think in terms of formula, because when you get these, we're going to do some other kinds of shapes. If you just think about, I just need to add all the sides together, typically that will actually get you better. But yeah, you can sometimes use formulas. So there's 22 plus 8, so it should be a total of 30 centimeters. Okay. Going around a triangle, again, just add all the sides together, because you're just a little person taking a walk. One side, this side, that side. Go all the way around. So 6 plus 6 plus 3. 9, 15. And that's miles. So that was a long walk. You tired? A little guy is, but anyway, okay. Parallelogram. So again, little person's going to take a walk. It's a little tricky here, so we've got 50, right? Plus 30. And then we come down this side. Now some people are going to say, well, what do we do with this 44? Do we use the 44? It's the height. We'll use that when we get to area. But when we're the little person walking around, we have to walk. We can't go through the we can't go through the wall. So we're taking the slanted height, or the slanted length, which is still 50. Right? So we're going to add. So in perimeter, we're not going to use that 44. You'll see we'll use it later. But that's probably the hardest thing with geometry, is knowing what to use and what not to use. And then we've got one last side to get back to where we started, and that's going to be 30 inches.
Do they put that 44 there in
Probably for this question, yes. In the future, they'll ask you for both the perimeter and the area, so you need it for one but not the other. So it's, yeah, so sometimes the measurements, we don't necessarily use all the measurements for all the things we're going to do. Okay, so this is 160, and it's in inches. And as you do these, you're going to find you'll need to put the inches in. Usually for the MAT141 stuff, it'll ask for units, so you put those in. So far, so good? Okay, so perimeter, just add everything together. You just remember that. Don't try to remember formulas. That's what always threw me off, because then you get them mixed up with the area formulas. Just remember perimeter, just take a walk around the outside and everything on the outside. And we're going to get some complicated ones, and if you remember that, you won't forget there's one question in here. It's also in the MAT141 homework, and everyone asks, or not, a lot of people ask me about it. After you're done with it today, we'll work that example, and I think you'll be just fine. Okay. So now we're going to find the area. Okay, now remember, area is how much, is like the question of how much carpeting we would need. So in here, the same figures, what we want to do is think of it, actually I could do it this way. So if this is 4 centimeters on this side, I could think of it as see, I'm going to need 1 there, 1, 2, 3, 4, and then I would make 11 this way, which I'm not going to do them all because I probably won't get them exactly right. But you could start seeing that area is about how many squares are in here. Already I can see my, not really good squares, but I'm going to have 11 centimeters along the bottom and 4 this way, so 11 times 4 will give us the number of squares to get the area. And since, oops, not times 40. Okay, 11 times 4. And it's centimeters, so really it's literally 11 centimeters times 4 centimeters. So we're going to get 44. But what we get is centimeters squared. Okay, so that's, or square centimeters. So this is another important part. On the Math AS homework, they will be asking you for what kind of units do you have. They'll give you the choice of centimeters, centimeters squared, centimeters cubed. Area is always centimeters squared. Okay. For the triangle, again, it looks like they gave us a little different one. But the triangle, remember, we could kind of think of it that we could duplicate the triangle. I don't know if I could draw it quite right, but you would get quite straight. But you could think of it this way. So if we do base times height, the area we're looking for is only half of that. Okay, so the base is 48. So 1/2 base times height. When we get to area, we're sort of now forced to use formulas, but we try to avoid that with perimeter. Okay, so we've got 1/2 times 48 times 38. Cross it out, right? The height is 38. Do the multiplication. So we could do 48 times 38 and then just divide it by 2. 912. And what are the units that we use on this? 912 what? Centimeters squared. Good. Or square centimeters, yes. So you can just imagine there'd be 912 little squares in there. Okay. Parallelogram. Now this is the one we ignored the 44 last time, but what do we do with it this time? So if you remember, a parallelogram is the full area. So the area of a parallelogram is simply the base times the height. What's our base? The 30, because that goes with this height. If we use the 50, we would need the height the other way. So we've got to use 30 as our base. So we're going to take 30 inches times 40 inches, or 44 inches. Sorry. 30 times 44, we get 1,320. And that'll be inches squared. Okay, so far so good. Seems real easy, right? Hopefully. Multiplying or adding. Perimeter, we add. Area, we just need to multiply. That's really the math involved. But then because we're counting stuff, making sure we're getting the right formula for the right shape. But if you from going through that, you really see everything is really base times height. Everything is base times height. Sometimes it's half of that because that's what we got with a triangle, but it really all comes off at just base times height. I remember the first time I learned geometry, I thought it was so complicated and we must be so smart to be able to figure this all out. And the more you look at it, you go, it's all just base times height. That's it. Even the circle is really, when that thing you saw, it's really just base times height. Oops. Clear this off. Okay. Circles, what ends up happening with the circle is, let me show you this, if I can do that. Okay, it's a little bit harder to do here, but if I were to take and we've got a center of a circle. Does anyone know what that's called? We use it to find the circumference is the distance around. So they use a new term for the perimeter. They call that the circumference. It's not the radius because the radius is only halfway across. It's a diameter. So this one is a diameter. The radius is half of a diameter. Okay. So if you know the diameter, you can get the radius. If you know the radius, you can get the diameter. It's half of a diameter. And that's the frustrating things with circles, is sometimes they give us a diameter, but we need the radius, and we use the wrong number. But if you eyeball it, if you took this diameter and you laid it around the circle, how many times around the circle do you think that diameter would go? There's twice. We still got another. So if I take that unit and go there, it goes 3 times plus how much more? Three times plus a little bit more. That's where pi comes from, is they just take the diameter, start laying it around. It goes 3 times, 3 full times, plus 0.14 of a diameter. That's where that number comes from. If you take a little string, it gets a little bit more accurate, but that's why we use pi. So if I know the diameter, if I multiply it by 3.14, that's what gives me the circumference. That's what gives me the distance around. So I can't really add all the sides because a circle, how many sides does a circle have? It's a little bit of a joke, so try to think. 2. What are they? Close. Inside and outside. So that's not really sides, but okay. My sister always used to pull that one on us. How many? So a circle has, yeah, the inside and the outside, but not really sides. So we use this formula to find both the circumference, distance around, and the area. So find the exact area of this circle. So area for a circle is always pi times r squared, the radius squared. So we saw that formula because basically if you cut a circle up into slices, you put the slices together, you get a rectangular sort of thing. If they were really small slices, the base is half of the circumference, which is pi r, and then you get the width, the top part is r, so you get pi r squared. Yes?
If you're given the diameter instead of the radius, isn't that equals radius squared?
If you're given the diameter,
yeah, if you're given the diameter,
you have to divide it by 2 first, and then
okay.
square it. Yes. So yeah. So again, so since they do give us the radius here, 50 centimeters, the way we're going to do this, and I'm going to emphasize they have a few things in here. The exact value is going to be pi times 50 squared. So we take 50 squared, which is 50 times 50. Is that going to be what, like 2,500 pi? They use this as the exact answer. Okay. And the reason is pi is not exactly 3.14. If you've ever seen it, it's got a lot of decimals that keep going on afterwards, and they don't repeat. They go on forever and ever. So to get accuracy, to get exact, you have to use that symbol pi. Okay, so when they ask for the exact, you're looking to put in pi. When they ask for an approximate, you can actually multiply it out and then round it, and you'll be fine. Now there is a little difference between using the pi key on your calculator and using 3.14. And actually, to do this, let's go to the scientific calculator, which has a pi on it here somewhere, I think. Oh, there it is. Okay. So we need this version of the calculator. So we're going to take 50 squared, which is 2,500, times pi, and notice it's more than 3.14, and it gives us 7,853.9816. The nearest hundredth, 0.98. Okay. So they're different. Oh, let's see. Skip B. Sorry about that. B, they wanted us to use exactly 3.14. So 2,500 times 3.14. 7,850. No decimals. So which one do you think is the better answer? C is probably going to be more accurate. And again, but it just depends on what you're doing with it. Yeah, if you're building something and that's in feet, if you use 3.14, you come up almost 4 feet short. You didn't get enough material.
Are they going to ask those two questions on the final? They're going to want to see the difference because I'm trying to figure out which one you would use.
They will tell you which one to use. They'll either say use a pi key. The final's all multiple choice, so it's they don't get ones that are that close to each other. So that's a good thing. So they're not going to be that exacting. Mostly what they'll do is it'll test whether you use, they'll give you the rate or the diameter, maybe 50, and whether you use 50 as the diameter, that'll probably be there. But you should use 25 for the radius. So those are the kind of things. So yeah. And again, since these are area, what kind of units should I have on these? Centimeter squared, centimeter squared, and centimeter squared. Now is this 2,500 pi, is that really of any value? Maybe not to most of us because we just don't, we can't look at it and tell that it's 7,800. But again, it's got the most accuracy. Okay, so that's about all we. So we just need to know how to do the calculations. We're not going to get into details about which one's better and this and that. Okay. So yeah, so here's one with, they do the diameter is all the way across, the radius is halfway across. So yeah, if we know the diameter, cut it in half, so this would have a radius would be 4. Over here, the diameter would be 50. And that's one of the, and when we're dealing with a circle, you just have to know whether you have a radius or a diameter. So find the circumference, and there's two formulas you can use for the circumference. One involves the radius, one involves the diameter. My suggestion is get used to using one and kind of stick with it. I like the one that the circumference is equal to 2 times pi times the radius. And notice those two, that's how they write it out, but the 2 radius goes together. You could also use the diameter times pi. So, which is easier if they give you the diameter, but again, it can get confusing. So this one over here, the circumference is simply going to be 2 times 25 times pi. So 50 pi. There's the exact form, and then you could multiply it out to get the approximate form. We'll just leave that for you later. So this one we could do it one of 2 ways. We could take the radius, which is 4, so 2 times 4 times pi, and you'll see that that gives us 8 pi. We could have just used the diameter, but it's just diameter. But the problem is if you don't do it a lot, you remember the 2, and you always use the 2 when you should and when you shouldn't. So again, use one of them and then just get used to it. And I think this is the one you'll see most often. So if you just get in the habit of using the radius all the time, you'll be fine. If you do it enough and you remember, hey, I could just use the diameter, that's fine too. Okay. And again, you'll have a formula sheet when you take the final, and when you're taking the tests and doing all the online stuff, it's open book, open notes. You can even get help. Again, I asked on the test you try to do as much on your own as you can to see what you've learned. Homework, definitely go ahead and get help. If you need help on the test, I'm not going to be real strict on that. If it helps you understand, though, try to do it in a way that helps you to learn. Because you can try it multiple times, but sometimes you try it enough and it's not working, frustration gets too high, it's time to call in some help. Phone a friend or something, right? Okay. The other part in here is we've got something called the Pythagorean theorem that goes with triangles. Does anyone know anything about Pythagoras? It's Greek, yes, a Greek society. I just remember his society, they had a secret handshakes and they didn't allow anyone to eat beans. So kind of, yeah, no beans. Beans. Yeah, I don't know but anyway. Now you know. So what he found out, though, is on a right triangle. So this corner here makes it the right triangle. That's what kind of a 90-degree angle. When we have such a thing, there's this relationship. You've got 2 legs that are off of the 90-degree angle, and then you have the long side, which is called hypotenuse, which is Greek for long side. Actually, one of my students Googled it, and that's what it came up at. I think it has a more abstract meaning, but Google said, yeah, hypotenuse, the long side of the triangle. So, 2 legs, and what ends up happening, if you were to draw a square off of the B side and find its area, and take the square off of the A side, that's not right, it would have those two, if you add the areas together, it would have the same area of the square coming off the hypotenuse. So that's just a relationship. It's just kind of a cool physical fact of the world. That's how things work. Okay, so what it's going to do is it's going to allow us to use this formula to find not area of the triangle, but particular lengths. What's that? You could, yeah. So if they might ask for the perimeter, but they only give you two sides, you need to find the other side. You need to find the third side to be able to do it. So yes, we could find the perimeter. So here's a couple cases. So if we were looking for the hypotenuse, what we're going to do is we're going to use this formula, but remember that gives us the hypotenuse squared. So to find the hypotenuse itself, we're then going to have to take the square root of it. So we'll take a squared plus b squared. So this is one formula that we'll use when we're looking for the hypotenuse. So in this case, it's going to be square root of 11 squared plus 7 squared. So we take the square root. 11 squared is 121. 7 squared is 49. And you could all just plug this in a calculator too. That gives 160, that's 170. Square root of 170. Which we could just leave as an exact amount, or we could pull up the calculator. And we'll do the square root. I think this calculator, I put the number in first, hit the square root button, and we see that that's 13.04. We'll round to the nearest hundredth, yeah. So it's going to be 13.04. And does that make sense? I mean, it's in the ballpark. If we just said it was 170, wouldn't that seem to be too long in comparison to 11 feet and 7 feet? I think so. Okay. Over here, notice we're missing one of the legs. So when you're missing one of the legs, the formula you want to use, and you could call it A or B, but we'll get this formula that A is equal to the square root. You'll see, basically subtract the b over, it's going to be c squared minus b squared. So there's those two. There's one where you add the two together, that's when you have the two legs. When you have one leg and the hypotenuse, that's when you're going to subtract them. Okay. So to figure out what this missing side is, we'll call it A. We will put in 12 squared minus 10 squared, and then take the square root of it. 12 squared is 144, 10 squared is 100, and we take the square root of that. Do the subtraction, we've got that this side should be the square root of 44. Sorry, this side over here. And again, we can take the calculator. At least visually, that looks like it should be shorter than the other two, right? So let's see what we get. 44, square root, 6.6. 6.63. Okay, so far so good. So those are the two types of Pythagorean theorem questions you'll get. They always got to give you two sides. If they only give you one side, we're stuck, pretty much. Unless they tell you it's isosceles, which means that two sides are equal, but we're not, I don't think we get there. Okay. If you take a trig class, you'll get into all that kind of stuff, but you use the Pythagorean theorem a lot whenever you're dealing with angles and triangles. Everyday life, not so much, except actually I was having some tile work done once, and my contractor unknowingly was using the Pythagorean theorem. he had a rope that had knots at 3 feet, 4 feet, and the other was 5 feet long. And he knew that if he laid that out on the tile, that the 3 feet and 4 feet, that the 5 foot, that they should all meet up. And if it didn't, it meant that it wasn't quite 90 degrees. And let's just do this. Let's example here. Well, actually, if this is 3 feet and this is 4 feet, and that's, can we prove that that's supposed to be 5 feet? Well, what's 3 squared plus 4 squared? 9 plus 16, which is 25, which is equal to 5 squared. So this is one of the, there's a few Pythagorean triples, they call them, where they're integer values, and the 3, 4, 5 is a triangle. He didn't know anything about a Pythagorean theorem, but he knew that his 3, 4, 5 foot rope would get him square tiles. I explained it to him, and he said, oh, cool. Let me get back to work. That's what he said. Okay. And so now, yes, we could find the perimeter now that we have them, but I've erased, so I'll let you do that. Again, just add all the sides together. I want to do a few of these where we get some complicated shapes, but that's basically, you pretty much have everything you need to do now. But let's take a look at a few of these, because this is the challenging ones. So, to do perimeter, right, we're just going to add all the sides, but here's the problem, is we're missing a few of the sides, right? We're missing this piece, and we're missing this piece. So how do I find what that piece is? Excellent. We take the 4 from the 7, because it's got to be 7 across, right? So 4 minus 7, or 7 minus 4, should give us that it's going to be 3 meters. Excellent. And the same thing sort of with this side, right? This is 9 all the way here. Here's 2, so shouldn't that be 9 minus 2? 9 minus 2, which gives us 7 meters. So if you do the perimeter, you're just going to add all the sides, and these missing pieces, 7 meters and 3 meters. So that's 10. Plus 2 is 12. Plus 7 is 19. Plus 9 is 28. Plus 4 is 32. So that was a little mental trick. Hopefully I didn't miss something. That's not too bad. How do I find the area, though? Seven times 9. Okay, so we could do 7 times 9, but that's going to give us the area of this piece as well, so then we'd have to find its area and subtract it off. That's one way to do it. Another way is we could just cut it here and do 4 times 9 for this piece. So that would be 36 meters squared. And then this little piece here is 3 times 2. It's too small to write it in there. So that's going to be 6 meters squared, and then we add these two together. 36 plus 6, the two pieces, and we will have 42 meters squared for the area. Okay? So that's the trick, is there's multiple ways to do these, but you're cutting things in pieces, or you're finding the area of a bigger area and then subtracting off the part that we don't have. And we'll see, we'll do this in a few others. Does that make sense? Okay. How about this one over here? What do we have? You see a square there, so 8 times 8. So there's going to be 64 inches squared here in the middle. That's what this dotted area. And we'll do the perimeter next because it's also. And then what do we have here in these two other parts? A circle with a diameter of 8. Good. And it's one circle, it's two pieces it's been cut, but we could just think of it as a circle with diameter of 8. So if we find that area, we would add it to the 64 and we'd have our total area. So the area of a circle, remember, is pi r squared. So if it's got a diameter of 8, what's the radius? Radius will be 4. So the area will be, we want to round to the nearest hundred, so yeah, we'll take 3.14 times 4 squared. So 3.14 times 16. Back to the basic. $50.24. Add that to the 64. $114.24. And it's going to be inches squared. I sort of skipped over the S for the perimeter, so let's come back and do the perimeter. And again, remember the perimeter is just a little guy, a little girl, a little person walking around. So they go this far. How far have they gone? 8 inches. Can they go through the middle here? No, that's the inside, so they've got to go around the circle. How much of the circle have they gone? Half of it. So, and then they go, oh, here's the other half. So I could just find the circumference of that circle, which is 2 pi r, which is 4. 4 times 2 is 8. 8 pi. So 8 times 3.14. So that little part of the trip was a total of 25.12. And then I add another 8 here. So 8 plus 8 is 16. That's 25.12. And that's 41.12 for the perimeter. And what are the units on the perimeter? Just inches, not squared or not cubed, just inches, straight inches. Okay. You see how this starts to involve some problem solving. You're just having to visually see pieces and say, okay, this piece and this. If I have half of a circle, I find the area and then I cut it in half, or find the perimeter and cut it in half. Questions? So we're doing okay. Okay, good. Well, these look, and then when I get to 3 dimensions, there are formulas for the sphere. We'll take a look at that. I can remember it. I have to look it up. When we have these other sort of pyramid, prism type things, you can think of it, it's basically you find the area times the height. So when you've got a cylinder, you find the area of the base, which in this time would be the area of a circle, and then you multiply it by 18. Over here we could do the same thing. We'll find the area of the base, which is going to be 64 times 6, and then you multiply by the height. So for cylinder type things, prism type things, it's the base, area of the base times the height. For a sphere, we're going to use this because we're going to need it in a moment. The volume of a sphere is 4/3 pi r cubed. Where does the 4/3 come from? I have no clue, but they figured it out. You could probably watch a video on how they got the volume of a sphere if you're really interested, but I lost interest. So we just need the radius. It's 3 feet. So for this one, volume is going to be 4/3 pi times 3 to the 3rd power. 3 times 3 times 3. 3 times 3 is 9, times 3 more is 27. So I'm just going to bring that up front. 27 times 4/3. Oh, but I could divide by 3, right? 27 divided by 3 gives us 9. 9 times 4 is 36. So 36 pi is an exact answer, and then if we multiply it by 3.14, we get the approximate answer. Oops. 36 times 3.14. 113.04. And what are our units? Feet cubed. Okay. I'll do this one as well. I had a question from a student earlier today who was doing this. And what they did is they took the base times the height and they basically multiplied everything together. So they'll take 64 times 6 meters. But then because they wanted cubic meters, they then cubed their answer. But that's overkill. We've already cubed the units when we've done this. We've multiplied the 3 things. So just take the multiplying, and then your units are going to be cubed because of that. So this one's simply 64 times 6 times 6, 2,304 cubic inches, or cubic meters. So 2,304. You doing okay? Okay, so we'll do maybe one more, the more difficult one, and because this has a lot of problems. We could probably spend a whole week going through all of these. Remember, as you get working on the homework, if you got one, and I don't have a video for them, I don't think I have that many videos for these, and it wasn't in today's, you could send me, and if you want to see a full video on it, I could do up a video. Just ask. Let's see. That doesn't look interesting. That's boring. Shall we do one of these? I think one of these, because I think there's one in the homework like this, and then there's one more that I want to do. So I guess 2 more problems. Which one? The big one or the 4 circles? 4? Okay. So the idea is that we've got paper 16 inches on each side. So we read through, we've got 16 inches here. So deciding whether to cut out 1 large circle or 4 smaller ones, which plan will result in the smallest amount of waste. Well, we'll do one of it, and I'll let you do the other. So how do we calculate waste? Well, we're going to need to calculate the area of the circles, right? And then the area of the square, and then just subtract the two. So what's the area of the square? (16 times 16). Length times width. Base times height. Okay. So that's going to give us $256, and then this is where it's a little challenging, but how do we figure out these circles? Good. Yeah, because 16, if you just bring it down here, this is 16, so these circles are cutting in half, so a diameter of a circle must be 8, right, half of the 16, and so a radius of a circle must be 4. Good. So this is the problem-solving part of it. We had to see they did give us the information, but we had to interpret it and say, yeah, it's 16 all the way across. So yeah, so if you want to do this later, this big circle is going to be simply 16 across, or you could use the radius is going to be 8. Okay. So we got a radius of 4. So to find the area of that, its area of a circle is pi r squared. So it's going to be pi times 4 squared, which is 16 pi, and 16 times pi, 3.14, is 50.24. And that's going to be in units of inches squared. So now do we take that minus the 256? What did I find when I found this area? The area of just one of the circles. Good. I need to multiply that by 4. And then when I subtract it, I'll figure out how much waste there is. Okay, so now I'm going to take this times 4, because that's one circle. So that times 4 is 296. So to get the waste, or the area in between, I take the 256, subtract 200, 0.9695. You cut that, didn't you? You remember. And actually, I'll show you something you could do. You could actually just take this 296, subtract 256. It's going to give us a negative number because we subtracted it sort of backwards, but the value's the same, just 55.04. So that would be the answer. That's the amount of waste, and that's in units of inches squared. Everything's in inches squared. And if you found the waste over here, you'd find which one has the least amount of waste. But I don't know. You either need a big circle or you need 4 small circles. It doesn't matter about the waste. But whatever you're going to make it, right? Okay, so I've got time for one more. Because this is the, and again, maybe we'll just set it up, but we'll let you know. This one you can see you're going to have two circles, subtract the two circles, and you've got the space between them. The gumball, the same thing. You've got two spheres, one that's 33 meters radius and one that's 30 meters. Get the two volumes and subtract them, and that'll give you how much gum is in that gumball. Okay, so I'll just kind of, but this one I want to do because it throws everybody off, including me. I messed this up the first time too. Okay, so it's and I don't know, what they'll do is it's the same, pretty much the same drawing, or maybe there'll be three little humps, but they'll change this, the radius. So they want both the perimeter and the area. So for perimeter, how do we find the perimeter? Again, if you do the little guy, it's going to walk. This is the part that most people will forget. They'll get the area, they'll get the circumference of the circular part, but they'll forget this straight part here. So if this is a 6-inch radius, how far is it from here to here? Remember, the radius is 6. So it's 6 and 6. It's 12 across here. So this is, yeah, that's the other thing, is sometimes if you remember it, then you use the 6 instead of the 12 in the diameter. So yes, it's going to be 4 times 12, or 48. Okay. So 4 times 12. So 48. They don't give units, so that's okay. And then what we have to do, we go over half of a circle, another half a circle, another half a circle, another half a circle. So if you want to, yes. 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 So that's the way. It's just two circles. So do the circle, and actually, since they're all the same size, just do this. Find the perimeter or circumference of 1, multiply it by 2. Good. So we've got a radius of 6. Remember, circumference is 2 pi r. So that's going to be 2, r is 6. So that's 12 times pi, and we get 37.68. For one circle. But we have 2, so we'll multiply it by 2. Excellent. So that's going to be 75. All the way around there. We add the 48 to it, and we'll have our perimeter. Oops, not times. Plus 48. 123. And then for the area, it's just 2 circles. So we just find the area of one circle, multiply it by 2. That one most people do okay with. You can kind of see that. So it's a radius of 6, so we get 6 squared pi, so that's 36 pi, and multiply that out. We get an area of 113.04. Again, we do have units, they're inches. So this will be inches squared. Perimeter is just in inches. That's one that throws a lot of people. That's including me. Think about it for a little bit. Okay? So I think that gives you enough to kind of work through the geometry unit. You can send me questions if you have them. Next week I'll be out, but that's where we'll be working on. Will be a substitute here who's done taught 141 before, I believe, and he will be here to answer your questions. He has a copy of the practice test, which is in Canvas, and again after Kaylee's presentation, then I'll make copies if you want to take one with you. If not, you'll find the link. The Friday after that, so not next Friday, the Friday after will be our last class meeting, and that'll be an opportunity to present in class if you'd like. Again, you can also record it and upload it if that works for you, and there's other ways to do it. You can also meet with me individually in my office. I've had a couple people do that. That's fine. And then I'll be posting, probably on Monday, I'll post the dates for the final exam itself, which will be during finals week. I'll have at least 2 different times, maybe 3 different times. If you can't make those, we can do it through the testing center. And there's also the option to do it, have it proctored online, but that costs $25 to $30. If we use a different service and they use your webcam. But if you can at least make it to campus, we can get you tested in a proctored environment. And again, if you go ahead and present earlier, you know what your points are, and you can kind of know where you're going to do it. You'll take it through MAT141, so the points that you get on the final, it'll be the points that's your score. So whatever, so it'll be out of 250. So if you have everything else done when you take the final, you'll know exactly what you need to get an A. It doesn't grade it while you do it, but it'll grade it at the end. Do you need a PowerPoint or anything?
Yeah.
Or okay. Perfect. You mind broadcasting? You want to keep doing it live? Or?
No.
Okay.
I mean, if you want, but I wasn't planning on it.
Okay. What I can do, let's see. Yeah, let's just take it down. So sorry, folks. This is a private presentation, but come back on Friday. We'll see what we can do. So yeah, I haven't. Actually, I think I can just close this and it will stop the live stream.